I'm sure most of you are already familiar with the motion design tool in Unreal Engine, especially since the release of the project Avalanche a few years back. Well, I've been battle testing it for the past few weeks and I just had to do this video for you guys, to showcase all the incredible new tools that leverage not only motion design, but animation as a whole, to an entire new level. Let me show you what it can do. Hop, before going any further, I really wanted to thank you because we are more and more on the channel and we reach 8,000 people, and that's huge. So if you watch my tutorials and you haven't subscribed yet, don't hesitate to join the community because it's really important. We are here every Tuesday of the week with a new video, so don't hesitate to join us to be, why not, a community of 10,000 people next month. I'm counting on you. I wanted to walk you through this little project I created using a variety of motion design actors, tools, and effects, alongside some of the more familiar elements like basic actors, the regular sequencer, and control rig. Speaking of control rig, I used a similar setup to the one I built for Squidward in one of my recent videos where I implemented dynamic secondary motion effects. Feel free to check out that video out if you are curious about how that was done. First things first, motion design in Unreal is a plugin. That's always how it works. So you want to make sure the plugin is activated and then give the engine a quick restart. Once that's done, you'll see a new mode available in the top UI along with a button that opens the motion design interface. And I didn't rely much on the motion design interface except for one specific window that I will show you shortly. So no animated letters, logos, or the kind of classic motion design elements you might have already seen online. The point here is to demonstrate how motion design is a real game changer for animation and effects. The spaceship's thruster, the star tunnel, and the asteroid belt were all created using motion design tools, no need for complex Niagara system or shader-based animation. With just two actors, you can pull off a ton of incredible effects now. For today, the focus is mainly on using cloners and effectors. Let me first explain the core concept and how to use these actors in any scene. As another example, let's consider an organic shape made of stars moving through the void. Activate motion design mode, then select the cloner actor from the actor section. Click once and then click again in your scene. By default, it's camera oriented, which is why the cloner might look tilted initially. In addition to enabling motion design mode, I also activated the motion design interface. In version 5.5, trying to create motion design actors without the interface being active can sometimes cause Unreal to crash. So don't hesitate to toggle that interface on and off as needed. In the outliner, you'll see the cloner actor itself with a static mesh actor parented to it. As mentioned, check the transform and reset the rotation to remove that initial camera-based orientation. Now let's look at the cloner's details panel. I won't go over every single attribute as most of them are pretty intuitive, and if you're coming from Cinema 4D for example, they'll feel even more familiar. The heart of it lies in the layout section, where you can define the initial shape of your cloner, from a standard grid to other primitives, or even based on other meshes already in the scene, which is super useful. Depending on what you choose, the options below will adapt accordingly. All of these attributes can be animated either deterministically through Sequencer or via the motion design toolset itself. By enabling range, you can add variation, randomizing the transform attributes like position offset, rotation, and even scale on a per instance basis. The step section affects the transform too, but it applies across the entire system of instances rather than per instance, influencing the cloner's overall behavior. Based on these inputs, let's create a random shape as a starting point. You can of course modify the shape of the initial static mesh via its parent actor by specifying any mesh you want, including nanite meshes if you want it. The transform component of that mesh can also be handy in addition to the cloner's own transform. Once your cloner is in place, it's time to bring in the second actor we mentioned, the effector. This is the one responsible for creating motion and dynamic transformation on the cloner using a variety of options. In version 5.5, you can now create a directly linked effector from the cloner's details panel, which is super convenient. Let's create one and take a look. Just like the cloner, the attributes here are pretty straightforward. From magnitude, which controls the effect's intensity, to color, a new addition that lets you tint the cloner without needing a special material, and the sections like shape, mode, and forces. Shape determines the effector's area of influence and how it behaves based on a curve profile for easing. You cannot create your own curves yet, but there are plenty of built-in options to choose from. In the mode section, you decide how the transform effect is applied. There are 5 different modes available, giving you flexibility in how the motion works. Another great addition is the forces section. With a single click, you can create velocity, traction, drag forces, and more. This can also be triggered in Sequencer just like with the Niagara system. That's what I did for the asteroid impact when the spaceship flies through in the original shot. So let's create a fun effect using the noise mode, which includes pan and frequency attributes. These let you simulate forces without actually applying them, and they are super easy to trick and animate. As you can see, color is automatically handled through the color attributes and the default static mesh color. In this case, the effect might be a bit hard to see due to the directional light color, but as you'll notice in the Thrusters effect I show you just in a moment, I've got much more control there, even over the emissive output. Let me walk you through how I set that up. We now have access to a pre-built material function offering a variety of outputs that can be used for different effects. In this example, I base my workflow on the effector total weight to drive the influence of the effector on the cloner using a LERP logic for the color. Color B is the one triggered by the effector, and I then inverted and subtracted the results to generate additional parameters for controlling the emissive intensity. Don't forget to enable the Niagara Mesh particle attributes in the master material. Otherwise, it won't function as expected. From there, you can create a material instance and start experimenting. With just two colors and the emissive attributes, you can build visual effects directly linked to the effector's weight and positioning. You can animate the effector manually through the sequencer, or you can use animators, a new feature in motion design that allow you to create LERP, bounce, or similar effects without needing to keyframe everything by hand. By right-clicking here, you can have access to the animator's effect directly, or you can have access to more advanced options once the motion design interface is re-enabled and the motion design outliner is visible. Clicking the small icon gives you access to the more detailed and manageable operator window. From there, you can adjust the range and behavior type and the animations place automatically. Though you still have the option to key attributes manually if needed. Additionally, you can take advantage of modifiers to create even more advanced effects such as booleans, masks, and more. Now that you understand the basics of cloners and effectors, we can dive into the other examples I built for this scene, starting with the tunnel and the asteroid belt. For the tunnel, I used a cylinder-type cloner combined with two effectors to achieve the overall animation. As the sequence progresses, the cloner gets gradually distorted through the scale transform. One effector controls the general motion effects, and in this case, I used the unbound shape, meaning it affects the entire cloner globally without needing a specific position. For the speed effect, something reminiscent of Star Wars, I used a plane-shaped effector. I keyframed its transform manually based on the ship's movement, mainly adjusting the Z-scale to give that elongated warp speed effect. Even in this single example, you can already see how fast and intuitive it is to create effects that would normally require a complex Niagara setup. It really is a game changer. I've got so many more ideas I want to explore with it. Feel free to share yours in the comments too. Alright, that was the tunnel example. Now let's move on to the ship. As you can see, I used a rig rail to constrain the ship's trajectory and combine that with an animation sequence to bring more dynamic motion. For that, I relied on the same control rig I mentioned earlier, creating a small looping animation that I baked into a sequence. Then I used that in the sequencer to bring a more energetic and fun vibe to the scene, which I think turned out pretty cool. Yes, the entire thruster effect is powered by motion design. It's a simple effect, sure, but the logic behind it is what matters here. One cylinder cloner is used for the main thrust, and a secondary circular one surrounds it. With noise effectors, adjusted with pan and frequency values, you get this floating, pulsing thruster effect in just seconds. What makes it even easier is that motion design now lets you create null actors so you can parent everything together neatly. In the sequencer, I simply used that null to constrain each thruster effect to the corresponding bond on the ship. Control rig, sequencer animation, constraints, all of these tools are seamlessly compatible with motion design, unlocking so many new possibilities. I'm generally excited about it, guys. For the final example, the asteroid belt, I used two setups. First, the belt itself is created with a mesh type cloner based on a disk mesh I modeled using the modeling mode. I also built a custom material using a gradient radial material function to generate some nice fall-off and color variation effects. Then I grabbed an asteroid mesh from Fab and used it as a static mesh component for the cloner. As for effectors, I placed a subtle one responsible for rotating the individual asteroids and two more for simulating the impact effect when the ship flies through the belt. It's really simple. I use forces, specifically a vector noise force. As I mentioned earlier, you can control all of these through Sequencer. I keyframed the Boolean toggle to activate the force trigger and adjusted the vector floats value to match the timing. The result is a clean, efficient effect built in just a few minutes. No need to touch Niagara or complex shader animations. And that's it guys, now you know all the secrets behind this scene and how to push your animation using the incredible new motion design toolset. So what are you waiting for? Dive in and give it a try. And that's a wrap guys, thanks for watching this video and let me know in the comments if you like this new approach of the motion design tools regarding animation. See you next week for a new one. Bye.